And my next guest joins me via satellite from Boston, Massachusetts. Now, we've been talking for the last several weeks with a company called Pressure BioSciences. Their stock symbol is PBIO. And recently, the company had a symposium at Harvard Medical School where a number of doctors and scientists assembled to talk about the technology that Pressure BioSciences has called pressure cycling technology. And our guest is Eric Bonneil. He's with the University of Montreal. Dr. Bonneil, can you tell us about the work that you're doing with Pressure BioSciences PCT technology, please?
Well, basically, I'm working at the Institute for Research in Immunology and Cancer in Montreal. So we're basically involved in monitoring protein expression changes or post-translational modification on proteins. And those changes when you compare, for example, cells across different conditions. For example, well, to put things simple way, like for example, we compare the protein expression in normal cell versus protein expression in cancer cells.
Now, prior to having access to pressure cycling technology, and I've asked the same question of some of your colleagues at the symposium, what did you do to accomplish what you're accomplishing now?
We use pressure cycling technology first. Well, honestly, we use the conventional way to digest protein, meaning like we digest protein overnight with trypsin and well, buffer like ammonium bicarbonate and tris-HCl. So it takes 18 hours. The thing is that it's at a significantly low throughput compared to using pressure cycling technology, where we actually achieve the same result in terms of protein digestion, but in 1 hour instead digestion overnight. So basically we were able to increase our throughput without losses of material and with the same results.
Well, besides that dramatic savings of time, what would you say are the other main advantages of PCT?
Okay, to be honest with you, we've been using the biorecycler for a relatively short time. So we were in the process of evaluating it, trying to find the best conditions to get what we want. The thing is that we're using as well the pressure cycling technology to monitor tiny modifications on protein like phosphorylation, which are actually involved in cell signaling, like vesicle trafficking, for example. And we were very pleased to see that by being able to even doing incomplete digestion of protein and generate longer peptide fragments, we were able to detect modification on protein that we were not able to detect with the conventional method.
Now, Eric, of course, you were one of the presenters at the Harvard Medical School Symposium. What's the message that you brought to the attendees?
Well, the message is that pressure cycling technology helps you in getting samples ready much faster. The reproducibility of the peptides of protein digestion in terms of peptide intensity is actually better than the conventional method. And basically we will also use it to actually monitor modifications on proteins like deamidation and phosphorylation that are actually not specific, well, in the specific case of deamidation are not specific when you're using the conventional digestion, because the digestion itself can create deamidation that are not specific to what's actually is inside the cell. But also by using it for phosphoproteomics and detecting phosphorylation and protein involved in cell signaling, where actually can be lost during the long digestion time when you're using the conventional method.
The company is Pressure BioSciences. PBIO is the stock symbol. Dr. Bonneil, thank you so much for your discussion with us. Just fascinating.
Thank you very much.